All right, what we're talking about today is we are working with slope and slope-intercept form. The first thing we need to know is what slope is, and slope is just the rate of change. And we look at, when we look at a linear function, it is the m. So slope, there's several fractions you need to remember. The first one is change over time. This is the one that's used most of the time for word problems. And then this is rise over run. That one's for graphing. And then there's the formula, which is used for coordinates. So again, the first one, this is for application problems. This one is for graphs. And this one is when you're given coordinates. But all of them give you the same thing. Okay, there are some different things about slope you have to remember. And so the first thing you have to remember is if a line goes up, it's positive. And if a line goes down, it's negative. Let's make that straight. If you have a vertical line, it's undefined. And if you have a horizontal line, it's a zero slope. And so that is slope guy. And slope guy will help you remember that if it goes up, it's positive. If it goes down, it's negative. If you have a vertical line, it's undefined. And the way you get an undefined is when you get a number on top of zero. You cannot divide by zero. So whenever there's a zero on the bottom of the fraction, it's undefined. And then the way you get a horizontal line, which is a zero slope, is when zero's on the top. So this one's undefined because you can't divide by zero, and the other one's just zero. All right, so let's go and do some examples. Let's start off by finding the slope of each line. So whenever you do this, the first thing I want to do is label x1, y1, x2, y2. I'm going to go ahead and put the formula here because we're going to need it. Okay, so now let's change colors. And so I'm going to plug in my y2 minus y1, so negative 6 minus 3, and x2 minus x1, so 5 minus negative 2. A negative 6 and a negative 3 is a negative 9. These become positive, so it's negative 9 over 7, which is falling. You do not need to make it a mixed number. It's actually better that slopes are not mixed numbers, that they stay in proper fractions. All right, let's do the second one. Again, I start off by doing x1, y1, x2, y2. And let's change colors. And so it's y2, 7, minus y1, negative 2, over x2, 4, minus 4, x1. So these two negatives become positive, and I get 9, but I get 9 over 0. This is undefined. This is a vertical line. And one thing I didn't talk about up above, but when it's undefined, just think about vertical lines. You cannot physically walk up a vertical line. You are not Spider-Man. There's not a Spider-Man in this class. So vertical lines are undefined. All right, let's look at this next one. I'm going to copy this formula. Try to, and bring it down here. Okay, and so now, and I'm going to insert some space, not enough space. So now what's going to happen is we are going to, given the formula, we have to find a missing point. So again, I'm going to label my points. This is x1, y1, x2, y2. So this time I know my slope. So I'm going to say negative 3/4 equals y2, which is 2, minus y1, 5, over 8 minus x. So now I have negative 3 over 4 equals negative 3 over 8 minus x. And so you see how I have the same number on the top here and here. So then that tells me that my bottom numbers have to be equal, because if the numerators are equal, then the denominator is equal. So my equation is going to be 4 equals 8 minus x. I'm going to minus 8 on both sides. And so I get negative x is equal to negative 4. So my x value is 4. And if I plug it in here, 8 minus 4 does give me 4, which I was supposed to get here. So we did it right. Okay, so that took up a little bit of space. So again, label x1, y1, x2, y2. So my slope is negative 1. So it's going to equal my equation, y minus y1, which is 1, over 2 minus negative 3. So I get negative 1 equals negative y over 5. I'm sorry, negative y. What was I thinking? It's y minus 1 over 5. And now we just think about how we're going to solve this problem. Well, we don't like fractions, so let's get rid of this divide by 5 by multiplying. And so those 5's are gone. And so I'm left with negative 5 is equal to y minus 1. Well, now we just add 1 to both sides, so y is negative 4. Now I'm going to look if I plug this in, I'm going to try it out. Negative 4 minus 1 over 2 minus negative 3. Well, that's negative 5 over 5, which is negative 1. So we did it correct. So sometimes you have the basic problems where you plug in, and problems like 3 and 4 are more complicated because you have to solve and find what missing piece it is that gives you that slope. All right, let's go back to our slope-intercept form because that was the last type of problem we'll have with slope. Slope-intercept form is y equals mx plus b. This is probably one of the most recognized equations in algebra. Usually when I ask a formula, people say y equals mx plus b, even if it's something totally different. But remember, m is your slope, which is rise over run because we're going to be graphing it. B, this is your y-intercept. This is the beginning. This is where you start. You always start on your y-axis. So let's look at this first one. The first thing I want to do is figure out my m and figure out my b. My b is the constant out here by itself, so it's negative 4. My m is the number in front of x. Well, there's no number there, but you know it's there, so it's 1 over 3. So I'm going to start with my b, so I'm going to go down 4. And from here, I'm going to rise 1, and I'm going to run 3. Rising is going up 1, and when I run, I always run to the right. And I'm going to do that again. Now this time, I'm going to go down, but I'm going to run the opposite way. Let's see if I can connect these. It's hard to connect them on the computer. And so there's my line. Okay, so let's go down and try another one like this, a basic one before we get into ones you have to solve. So let's go ahead and try number 5. So the first thing you should find is your m and find your b, and then we're going to graph it. So hopefully you found your m was negative 2. Now, if I don't have a fraction, I need to make it a fraction, and I can make it a fraction by putting a 1 underneath it. And my b was 5. So I'm going to start at 5. Now, since my top number is a negative, I can't rise a negative, so I actually go down 2 and over 1. Down 2, over 1. Down 2, over 1, and I continue that pattern. So these should look familiar to you, but that's the process. Remember, you start with a b, and then you count your rise over run. All right, let's go up here and look at another one. And the reason we're looking at this one is because this one's not set up right. It has to be y equals mx plus b. I have to have y by itself. So I have to subtract 2x to first of all try and get y by itself. So I get negative 3y. These cannot go together, so I just rewrite them. And then this is times negative 3, so I divide everything by negative 3. And so what I get is I get y equals, remember what happens when you have two negatives? They become positive, so it's 2/3 x. Same thing here. Negative 6 divided by negative 3 is a positive 2. So now my m is 2 over 3, and my b is 2. Remember, you start at the b, that's the beginning, so I start at 2, And I go up 2 over 1, 2, 3. Up 2 over 1, 2, 3. And then I go the other way. And I graph. There you go. But again, the first thing I had to do was I had to solve for y. If it's not solved for y, it's not going to work. You have to solve for y first. All right, so let's try a couple examples. When you look at number 6, my y is almost by itself, but I have to divide everything by 2. So I end up getting 2x minus 3. So my m is 2 over 1. That's right, there's a 1 there. And my b is negative 3. So I'm going to start down at negative 3. And I'm going to go down 1, 2 over 1. 1, 2 over 1. So because it was a negative, I always do my negative up and down. I very rarely go to the left unless I run out of space. All right, let's look at this next one. Oops. Let's look at this one. So I'm going to subtract 3x. So I get 4y is equal to negative 3x minus 4. Remember, they're not like terms, so you can't combine them. I divide everything by 4. And so I get y is equals negative 3/4 x minus 1. Remember, you start at the b, so I'm going to start here at my b. So I go down 1. And then I'm going to go down 3 and over 1, 2, 3, 4. And then I don't have space, so now I go up 1, 2, 3, and over 1, 2, 3, 4. So 1, 2, 3, 1, 2, 3, 4. So because I'm going the opposite way, that's why I go to the left. Okay, last one, let's change color. There's a lot of red on there. So first thing I'm going to do is I'm going to subtract 2x. And I get negative y equals negative 2x, and that's a positive 1. Don't forget this negative. A lot of people will forget this, but that negative's there. And so I have to get rid of the negative by dividing everything by negative 1. So I get 2x minus 1. And so now my m is 2 over 1, and my b is negative 1. So I'm going to start here. Start at negative 1. And then I go up 1, 2 over 1. Up 1, 2 over 1. And that's it. Okay. So remember, when you're doing y-intercept problems, the first thing you have to do is you have to make sure y is solved for y. If it's not solved for y, solve for y. Next thing you have to do, remember, you start at b. That's the beginning. That's super important right there. Start at b. It's a horrible start. And then you count the slope.